Good morning, good afternoon, good evening, whatever and wherever you are. My name is Anna Rochelle, and today we are going to talk about Big Ideas, Algebra 2, Chapter 7, Rational Functions. This was sent in by a student. It's a 2-page review sheet for Chapter 7 on rational functions. There's going to be some graphing and solving rational equations in the next video. In this one, we're mainly simplifying and adding, subtracting, multiplying, dividing, all these rational expressions. Okay, so without further ado, let's go ahead and let's get started. The first set of problems is just to simplify. And in order to simplify, just like we simplify any fraction, our goal is to really make sure that we have our numerators and denominators as simplified as humanly possible in order for us to be able to cancel things out. So let's take a look at this one. In order to simplify this, in order to factor this out, I know that I can pull an x from each of these terms. So I'm going to end up with x and then x plus 3 as a fully factored expression in my numerator. And then in my denominator, I'm just going to go ahead and factor because it's a trinomial. I couldn't do that in the top because it was a binomial. I'm going to pull x and x for each of my first terms. And then I know 6 is just 2 times 3. And because they're both positive, I know it's going to be positive 2, positive 3. So the very first thing that we're going to do is we're going to notice that I have x plus 3 and x plus 3 in the numerator and denominator. So I'm going to go ahead and cross those out because those are fully simplifying. And then I'm going to be left with this x over x plus 2 as a final answer. Now, in this particular case, the instructions don't say to identify the restrictions, but we are going to identify anyway. So a restriction is essentially something that our variable cannot be when we go in and solve the problem, because our function or our full expression is going to end up being undefined. And as we know, something undefined is super taboo. We cannot have anything that's undefined. So we want to restrict that value so that we don't have that undefined piece. Okay, so because we eliminated the x plus 3, what we're going to do in order to find the restriction is we're going to take this x plus 3 and set it equal to 0. So our domain is going to be all real numbers except when x is equal to -3. So that's also part of our answer. It's not just this fully simplified, I guess in this case, it's not yet a function, it's just an expression, but our domain would be that. Okay. Moving on, we're going to do the same exact thing, but we're going to factor things out. So instead of writing it off to the side, I'm just going to factor things here. So in this one, I'm going to go ahead and I'm going to factor 3x and x. I know I'm going to want 2 over here because the 3 and the 2 multiply to get 6. And then the 1 and the x is going to multiply to get another 1. So 6 plus 1 is 7, exactly what I want. So this kind of now cancels out and it's replaced by my blue ink. Then this bottom piece, since I don't have an a, is greater than 1. I know it's just going to be x and x. And then I know this is going to be 2 and 1. And I'm going to go ahead and do plus for both. So now this blue ink replaces this original problem. And I notice that I have this x plus 2 on top and on bottom, so I can simplify those. So in order to fully simplify my problem, I'm going to have this 3x plus 1. And regular x plus 1. Now, if you're going to want to crush my soul and, show me how much you don't love me, you would actually cross out this x plus 1, and just leave it at 3. But we can, in fact, not do that because 3 does not get factored out from here. And so it's not factorable. Because the 3 is not factorable, then you can't factor it out. So, for example, if I had like this in the numerator and this in the denominator, then yes, I would be able to cross these guys out. But because the 3 is meshed in with this x and it's plus 1 altogether, I kind of can't do that. So we're going to just leave it as is. And then our domain is going to be all real numbers except x cannot equal this -2 because I'm going to set this x plus 2 equal to 0. And so all real numbers except not that. And that's the end for simplifying and finding that domain. So now here, just saying to perform the indicated operation. In some cases, I've seen teachers expect a restriction for these as well. In here, it doesn't say, it did say it in the last two problems as like a practice questions, but in these four, there were none. So we will not be finding the domain for these next four problems. Okay. So we're going to start with multiplication because multiplication is like the more basic one. It's something that students are really used to, accustomed to when you multiply things and you can factor them and then you can simplify them. So very similar to what we were doing in the past problem. Okay, so I'm going to go ahead and I'm going to factor this and I'm going to factor out an x and be left with x minus 2. And then I'm going to go ahead and factor out this top as well. And I'm going to end up with x plus 3 and x plus 2 over here. Just kidding. I'm going to end up with x plus 5 and x plus 1. Yeah, there we go. That's much better. The other piece was no good. So I'm essentially replacing these guys with these fully factored forms. So when I look at this, and let's just clean it up a little bit so that I can fully explain what's happening here. I have x plus 1 over here, and then 3x. So I'm really essentially trying to find things that are the same. So for example, in here, I have this x plus 5 and this x plus 5. That's the same exact bit, right? Then I'm here with an x over here. So I'm going to cancel that x out with this x out. Because they're the same exact terms, I can simplify them, I can eliminate them. And so what happens is I'm actually left with x minus 2 and x plus 1 on the top in the numerator and 3 in the denominator. This is my fully simplified version of this problem. So I just go in and I'm done. If I were asked to restrict the domain, I would just say everything that I canceled out. So not 0. Let's actually do it. X is not equal to 0 and it is not equal to -5, but it is all real numbers. Because I'm setting this green x and this x plus 5 into my, to equal zeros. Okay. So before we start talking about addition and subtraction, I want to go over and make sure that we understand that when we're working with fractions, the first thing that we're going to do is we're going to actually create common denominators when we add and subtract. So before I do any math in this, I want to make sure I get common denominators so that when I do go in to add things, that I can actually be like, oh, hey, yes, this is exactly what I'm looking for. Okay, so normally when I look at fractions that are subtracting or adding, I can go in and I can take this plus, this negative, this subtraction, turn it into positive and make this a -4. I'm going to do that because I know what the answer is and I know that it's going to be easier. But also you should get into that habit of changing that subtraction problem to an addition problem and turning this second numerator into a negative. It's going to be super duper helpful. Okay. I also know that when I create common denominators, I'm going to actually multiply the other fraction by whatever this denominator is. So I'm going to multiply this by x plus 2 and x plus 2 in the top and bottom, numerator and denominator. And then here by x minus 1, again, top and bottom. Looking at my denominators in both cases, I have an x minus 1 and I have an x plus 2 in both cases. The plan is not to rewrite them over and over and over again. Even if your teacher says that that's a good idea, it is not. It takes too much time, extra work, and it's not necessary. So instead, what we're going to do is we're going to focus on the numerator. So my numerator, just to clean it up a little bit, is this 2 times x plus 2 plus this -4 times x minus 1. You don't have to write it down every single time in this fashion. I think this particular step of cleaning it up doesn't have to happen. But in order for me to explain the process to you, I think it's really helpful for you to see what's happening. Okay, so then I'm going to distribute this 2 and this -4. I'm going to end up with 2x plus 4 minus 4x plus 4. I'm going to go ahead and I'm going to combine these like terms. So I'm going to end up with negative 2x plus 8. And actually, I can factor something out from here. So I'm going to go ahead and do that. I'm going to factor out a -2 because I usually want my variable, my highest exponent variable to be positive, right? So I'm going to leave it as x minus 4 on the inside of the parentheses. And now is when I'm fully factored, I'm fully combined, I'm fully distributed, I'm fully whatever, right? I can now go in and add my denominator of x minus 1 and x plus 2. And then this is going to be my final answer. Okay, so all I've done is just created common denominators and added both fractions. Now this one is a little bit different because in this case, I already have this x plus 9 here, but here I have an x squared. So I'm going to go ahead and factor this first in order to figure out what I need to multiply in order to create common denominators. Okay. So my money's on this x plus 9 being a factor over here, just because it's an Algebra 2 class, so we're not getting crazy pants, right? And I also know that 9 times 2 is 18 and 9 minus 2 is 7. So ta-da, I've got my answer, right? So because in this particular fraction, I already have this x plus 9 and x minus 2, I don't have to multiply this by anything. I'm going to leave it as is. But my second fraction, I don't know what's going on with my voice. My second fraction, I do actually have to go in and take a look at this x minus 2, and I do have to go in and multiply that out because it's not there. But when I multiply this numerator and denominator by x minus 2, you'll notice that my denominators are now the same, and then I can really focus in on my numerator, just like I did in the previous problem. So again, you don't have to clean things up, but I do in order to show you. So you don't have to do this step. You can kind of do that piece in your head. If you want to do this step and clean it up and show it, that's totally fine. In fact, I would encourage that only because I really like seeing like a follow through process. But I'm not your teacher. I'm not grading you. So, you know, it's cool. So I'm going to have 14 plus 6, and then in parentheses, x minus 2. I'm going to go ahead and distribute that. So I'm going to end up with 14 plus 6x minus 12. I know I can combine these two, and this guy's on his own. So I'm going to end up with 6x plus 2. I can factor 2 and be left with 3x plus 1. And then my denominator, I know from here is actually this piece, right? So it's going to be this x plus 9 and x minus 2. And then this is it. This is my final answer because I can't simplify anything. So I'm going to leave it as is. Okay. So we've done multiplication, we've done subtraction, we've done addition. Now we're left with division. Another thing that I want to make sure that I make a note of before we start this problem is all the rules for fractions still apply to these problems. These are just fractions on steroids, right? These are like fancy fractions. They're excessive, right? They have a lot more going on, but at the base, at the very essence of these problems, these are just fractions. So when I divide fractions, I'm going to go ahead and keep change flip, right? So in this case, when I have a division sign and two fractions, I'm going to go ahead and keep change flip too. But in order to start this, what I'm going to do is I'm going to actually factor this out first, and then I'm going to show you how I keep change flip in the process. Okay, so I'm going to start factoring this guy out, and I have this x and x over here. I know that 2 times 3 gives me 6, so I can do plus 3 minus 2 to get this positive 1 here. And then I have this guy is x and x. I'm going to say it's positive 3 and positive 4. And now what I'm going to do is I'm going to actually multiply and flip the fraction in my head. So I'm going to factor this guy up top and then this guy down below. That looks like a really creepy smiley face. So we're just not going to leave that there. But so you're aware, it's the top piece is going to go on the bottom and the bottom piece is going to go on the top. So I'm going to flip in my head, but I'm going to factor things out here. Okay. So this guy is the one that I'm factoring up top. So I have 3 and 4 as well. I could do a positive 4 and maybe a negative 3 in order to get this negative 12, but also reach positive 1. Then I'm going to go in here and I'm going to have x and x. I'm now looking at the numerator, right? So I'm also thinking that might be negative 3 and negative 2. So when I look at my fractions, I'm actually going to go in and I'm going to cross things out in a hot second. Okay, here we go. I have x plus 3 and x plus 3. These guys can cancel out, no problem. X minus 3 and x minus 3, these guys can also cancel out, no problem. I have x plus 4 and x plus 4, I can cancel this way, also not a problem. X minus 2 and x minus 2, also those can cancel, not a problem. So not only can I cancel top and bottom within one fraction, but I can also cancel side to side between fractions so long as one of the factors is in the numerator and one is in the denominator. What do I mean by that? So as like a reference, right? When we look at, for example, 2 over 7 times 14 over 8. I know that I can simplify this way by dividing both by 2, right? So this would be left with us 1 and this is 4. And then I can do the same thing here, dividing by 7. And then I can do this here as well, 2 and 4, and end up with 1 and 2. In this particular case, it just so happened that I crossed everything out, but the process is still the same, right? The idea is still the same. We're simplifying as much as we possibly can. So my answer to this, fully simplified, would just be 1. My domain would be all real numbers, except when x cannot equal. And I'm going to take everything that I crossed out, set it equal to 0, and then say that that's my restriction. So x plus 3 is equal to 0. I cancel that. So negative 3. The plus 4, so negative 4. The minus 3, so regular 3. And the minus 2, so regular 2. So the domain would be all real numbers, except for when x is equal to all of those, because then it would be an undefined function. Okay, last section of this particular piece, and one of them was on the review sheet and one of them was not. I chose to do both just to give you an example of both in particular so that we know and we understand what's happening. I'm going to go ahead and start with this one to show you one method, and I'm going to do the other method with the other fraction problem. So what I like to call these is I like to call these super fractions because they're fractions within fractions. And that is so fun because you get double the fractions. Amazing. Okay, so in this particular case, what I'm going to do is I'm going to focus on the denominator first. And then once I have that denominator, I'm going to go in and focus in on the division. Because technically, as this big fraction right here, this means I have 6x divided by this whole bit down here, right? So I want to go ahead and change this first. So again, this goes into as an addition problem like we did in that second set of problems. I'm going to go ahead and I'm going to multiply this by x over x to create common denominators, this by x plus 1 over x plus 1. I don't have to focus on the denominator for now because I don't need to. I'm going to simplify. So I'm going to end up with 4x plus, because I multiplied these, 4x. And then I'm going to distribute those in my head. And I'm going to end up with 6x plus 6. And then actually before I even write this over whatever my denominator is, I'm going to combine these two. So I'm going to end up with 10x plus 6 over this x times x plus 1. And because I can't simplify anything, I'm just going to leave it as is. But I do want to note that my original problem said 6x, right? So I have this 6x over 1 divided by this whole business here. So instead of that, I'm going to do 6x over 1 times x, and then times x plus 1 over 10x plus 6. So actually, I totally forgot to factor here, but no worries, I can factor here. I know that 10 and 6 are multiples of 2. So I'm going to pull a 2 here, and I'm going to be left with 5x plus 3. So that guy goes away. And I can't really simplify anything except for this 2 and the 6. So the 6 will become a 3. So my final answer to this problem is going to be 3x squared, because I'm going to go ahead and I'm going to multiply this x here and this x here, and the 3 is going to stay in front, times this x plus 1 over 5x plus 3. Final answer. So the real piece here is to understand that in this superfraction, my numerator gets divided by my whole denominator, but I really want to focus in on just the denominator first and then do a division problem like I did in that second set. Okay. In this piece right here, in this problem 2, what I'm going to do is I'm going to actually multiply my entire fraction. And you could do parentheses or brackets or whatever, it doesn't really matter, by whatever is in my denominator. So here, instead of looking at two fractions separately, or two, like the numerator separately from the denominator, I'm going to look at it in a whole. So I'm going to multiply every single one of these terms by 10x, because 10 and x are part of my denominator. Okay. So when I do x over 10 times 10x, technically my 10s will cancel, right? Because it's going to be over 1. So I'm going to be left with x squared. And then negative 3 times 10x is going to be negative 30x. Then I'm going to have that over 5 times 10x is 50x. And then in here, my x's will cancel, and I'm going to be left with just this plus 10. Now, this looks very similar to that very first problem that we did, where we can factor this and see what we can simplify. So in here, I can only pull an x from the numerator. So I'm going to have x times x minus 30. And in my denominator, I can pull a 10, and I'll be left with 5x plus 1. There's not much that I can simplify here. And final answer. I hope that this was helpful. I'm going to go ahead and record that second video in a little bit and post both of them together at the same time. The other bit has a little bit more of solving and graphing. I will see you in the next video. Bye.